Good morning, and thank you so much for joining me in my shop here. It's May 25th today, and I didn't think I'd be doing any more work on this radio, on a video, but I am. I thought of something that might be interesting to do with this radio. But I ended the last video saying I was just going to clean up the cabinet, and then pretty much that would be it. But look at the situation with this cabinet, which I did not clean up. Right? I spent some time, you saw me working on this edge here. I didn't do any more to it because of this. You see, I imagine this powdery material, this white stuff, had kind of fallen on the radio. But it's all underneath it too, like underneath here. So how did it get there? I mean, this is sitting somewhere and dust is falling on it. It would build up on these upper surfaces, and there would be nothing underneath. But it doesn't stop there. Look in the holes here. It's all white all through here. The holes where the volume control protrudes. Look, it's white. Well, a little bit's knocked off at the top. What exactly happened to this radio? I didn't even look at this. There's white all down. Oh, this feels like paint. This really feels like paint here. So this sticker. So there was a large sticker here. Well, and then they painted it with white paint. Doesn't make any sense. Well, that's what happened. Nothing made any sense. When you look inside it, there's overspray everywhere. There's white overspray. Was this once a white radio? And somebody managed to get most of it off the flat surfaces. And they just couldn't do what I started working on in these edges. And they certainly wouldn't do in these holes, and ended up with a kind of a bad result. It's got to be it. It's got to be the case. I'm actually picking paint off this thing. Yeah, it's clearly been oversprayed on the inside. Well, that's surprising. Somebody would try to remove that paint. Wow. And so this is all scratched up on the surface here. A little bit of wax, just ordinary furniture wax on here would probably get rid of most of those scratches and make them invisible. That's all scratched through here. Now that I look at it, that's the story here. This was white. And somebody, I'll bet you it was white, and the white paint had flaked and looked terrible, and somebody thought, well, let's just, look, it's brown underneath. Let's just remove it all. And this is what they got to. They got this far and said, you know what they said? They used a word that started with the letter F. Yeah. Okay, so getting back to the radio. I was thinking a little more about this. I think there's something interesting here, and that's worth going a little further with it. Let me just pull the plug here. So when I was, excuse me, experimenting with the IF tuning, just moving it a little bit to see if things got better or got worse, and they generally got worse. So it looked like this is probably tuned correct, but I mean that's hardly an alignment check. It's just a real rough thing. One of the things I noticed is that this, I believe it was this particular trimmer here, as I made the radio's sensitivity increase by turning it a bit, I got to the point where the radio started squealing. And I think the comment at the time was, well, that's probably because of a decoupling capacitor that's not doing its job anymore, and I just moved on. Well, that's interesting, isn't it? Isn't that interesting? Isn't that really what this is kind of all about, working on these radios, is having a misbehavior take place, and then using the power of the human mind and information to sort out what it might be, and then find out if you got it right. That's kind of the fun part of this thing, this stuff. So that's what I want to do. I want to say, okay, excuse me, for some reason, it looks like if you peak up the IF to its peak, the result is oscillations. Well, that shouldn't happen. The radio's designed not to do that. It has features in it, particular capacitors, to prevent that. So what I'm proposing is we take a look at the, and not much work has been done on this radio. I'm proposing take a look in the, or at the schematic, and try to take a guess as to which one of these capacitors, excuse me again, 1, 2, 3, look at that. Can you see that? That ugly guy up in there? He's ugly. One of those is probably causing the situation. There's a big whack of solder right here. For reasons unknown. Okay, so, simple. And you know what? This resistor looks cooked. Now that I look at it. Doesn't seem to have the colors looking quite the way it should. So this one here. It's a slightly higher wattage resistor. See, this one's a tiny bit smaller. They're expecting some heat in this one. And then that's right. Look at this guy here. Don't poke around with that thing. Pretty sure that's a capacitor. Yeah, even after all these years of doing this, I'm still a little unsure about things. Yeah, that's a good place to be. Okay, so schematic next. We'll take a guess as to which capacitor could be responsible. We'll take a guess. I'm already taking a guess that it's a capacitor. We'll take a further guess on that guess which capacitor it is. We'll change it and see if the phenomenon goes away. Did I hear a cat here? Did I hear a cat meowing? Well, there he is. She is. Yes, what? You want to go outside? Do you want to go outside? I think cats, you know, they look at us when they want something like that, and they think it should be obvious at this point what I want, and they wait for stupid humans to figure it out. That's why they spend a lot of time managing the stupid humans around them. Okay, here's the schematic for the radio I'm looking at. It's a model 5049, a Sparton 5049. So I've glanced at this quickly before I put it on the screen here just to make sure it's the same. And look, there's that funny angle trimmer that had popped off here that I've soldered back. And otherwise it looks exactly like this, but it doesn't quite look exactly like this, because I believe it's this one. This IF can is actually turned about 30-40 degrees. It's not square like you see it here. It's actually on a funny angle. Kind of funny angle like this. But other than that, I think this, for sure, this is the correct schematic. Oscillations, undesirable oscillations in the IF. Well, we don't know. You know, I'm assuming that probably it was, don't know which trimmer it was. One of these 4 capacitors I was turning when the radio broke into oscillation. So the idea here, the basic idea, if my what I'm suggesting is true, is the output here is somehow getting back to the input over here. We don't want that to happen, that's for sure. It has a couple of paths it can do it on. One is it can go back, and believe me, this is just me talking. If I can have this wrong, so you know, don't take this to the bank right away. So it could come back on what would be the ABC line. ABC line is almost certainly here, and you can see the ABC line, of course, is hooked up right to the grids of these tubes. Now, it's isolated by fairly large resistors. There's one here. This will be a really big one here. A couple megohm or something. Actually, the table of parts is just over here. Let's take a look. R3, 2.2 megohms. I don't think it's 22. I think it's 2.2. And this R1's probably a megohm. Half a megohm here. And this is part of isolating away the output from the input. But that's not the big part. The big part will be this capacitor here and this capacitor here. So I believe this one's job, because it's on the, let's call it the input side of this big fat resistor here. This guy's concentrating on draining out any RF, or eliminating RF, however you want to phrase it. And then, this guy's job here, C10, this is probably a 0.02 or 0.05, how about a 0.01? It's a 0.01. This guy's job is twofold. One is to get rid of any signal that's come out of here and it's on its way over here, to get rid of it at this point, or to force this line to be at the same signal voltage as this line. This is the B minus up here. And therefore, no signals, if any of the signals which are not completely drained out by this guy should make it through here, I mean, some portion will, it's just mathematics, right? That portion will be crushed, I tell you, by this capacitor. And so nothing coming out of here can make it all the way back to here, or back to this grid. So we got two capacitors implicated in this. One is this RF one, and the other one is this one. Now this RF one is probably pretty small, C13, 250 picofarad mica capacitor. So the chance of this being bad is much lower than the chance of this one being bad. The C10 here was the 0.01. This is the guy who's probably responsible for the effect. And if I just replace this one, we probably eliminate that effect. For sure? No, because there's another whole series or way in which signals can travel through the radio, and that's right on the B plus line and into the screens. Typically when you have trouble with this, you get a pulsing type of feedback, commonly called motorboating, because it makes a put sound, and it's this thing charging up and discharging and changing the gain of these stages. So at some point the gain is dropped, the signal drops, the effect drops, the gain goes back up, the signal is loud, some leaks back, and it goes up and down, put, because of this thing. I didn't hear any put. So based on that, you know, maybe this one, maybe that one, maybe I'm entirely wrong about the whole thing. That could be. Order of work. We're going to have to make the radio make the problem again. And with the problem in place, we would change, you know, one and then the other. Which one should we do first? Do the more unlikely one first. So which one would that be? No put. This is the more likely capacitor. This one's on its way to being changed anyway pretty well, because you know, it's an old wax capacitor and I'm practically got my soldering iron hot now. So I think this one, let's do this one first and see if the put all goes away. And maybe that's it. Maybe I won't do any more. By the way, there's an interesting thing about this radio. If you look on the back here, you see one fanshawe connector. There's another one. There's two fanshawe connectors on the back of this radio. I wonder if Mr. Fanshawe knew he was going to be immortalized by this little clip here. So, interesting. Short antenna, long antenna, and loop antenna. Well, this is a little unusual. I've never seen two inputs here. Whoops. So what can we learn from this? So short antenna, we look on the schematic here. We see long antenna. Well, where's the short antenna? Here? This must be the short antenna. Don't tell me they didn't write short antenna. Oops, I'm sorry, my fingers keep clicking the mouse button here. I guess you could have guessed it was my fingers. I don't actually see them say short antenna, but we'll have to assume this is the short terminal here. So what's happening? So you have a short antenna with a less signal on it. So you're feeding less signal in here. It's got to get onto this grid. It's got to get there. this away through the loops of the antenna, and then we meet a connection here. Well, this is kind of weird, isn't it? It kind of splits here, up this way or over this way. Okay, so whoops. So if you don't have an antenna connected here, we can pretend none of this exists. So we'll just be coming in here and go around and around the loop, because you want to get to the end of the loop that's connected to the no, not the ground. Let's try this again. Connected to the grid. Well, it's connected to the ground. Okay, I'll take that back. Well, let's forget these antennas for a minute. What's going on with the loop antenna? So the loop antenna got quiet. Let's try that again. What is the grid connected to? Okay, and then okay, can't figure this out. It's just not coming clear to me what they've done here. So I thought this would be a great learning experience, but no, another experience of confusion. Let's look at the size of these two capacitors, C5 and C22. C5 is 0.003 and a C22 0.003, same size. Okay, so the only variation would be the length of the antenna. If you're putting a long antenna with more signal, this must be closer to the grid, I would say. You know, they haven't really shown all the turns here. Maybe that's what's making this unclear to me, but I'm not quite getting it here. Interesting to note, though, there is no antenna transformer in this radio. Pretty sure this is not functioning as a transformer. It's got a couple capacitors connected to it. It's got a terminal strip, a couple capacitors, and 4 wires going into the loop. You can count 4 wires going in the loop. 1, 2, 3. Well, kind of. Gee, I don't know. Okay, get away. Run away from this quickly. This is not. Run from that. It's just an academic experience anyway, and it looks like I've failed the class, so we'll just move on to the next class, I guess. Okay, so the name of the game then is make this thing oscillate. I can identify where this is. Look, it's right on this coil. This coil is the local oscillator, associated with the local oscillator. It's a transformer. We should be able to find this pretty easy. And it was a 0.01. Okay, let's go look at the radio here. If you're new to my videos, you should have by now realized that I'm doing these things live. I'm just winging it. So if there are times where I make mistakes and stuff like that, it's just par for the course. Okay, if I make mistakes. So, see all the wires here? Look at all this stuff. 2 wires down in here, coming into kind of the center or some depth into the coil, and another wire over here. This is even a wire coming right off the antenna. It's over to a ground terminal. Yeah. Ooh. Simple looking, but maybe not so simple. So I want to operate the radio now and adjust this and get the squawk. Oh no, we want to find that capacitor first before I do that. I want to find that capacitor. Okay, I said it was associated with a coil. Where's the coil? Where's that? There's a coil here. And who's associated with that? Can I spot a capacitor essentially connected to it? Oh, it's this one. But that's not what I'm looking for. Can't be this one. Can't be this one. Can't be this one. Can't be any of them. Wait a minute. Wait a minute now. There's no coil up here. No, just the antenna is the coil. Or the antenna. This is definitely the right coil. I'm following the wires coming from it. So this capacitor is connected to this terminal. There's a brown wire going around to this terminal. And then there's another brown wire coming up underneath this, you can't see it, and tying to one of the terminals. This is probably the capacitor here. Even though it's on the end of a... And so this is a... Well, I'm trying not to disturb it too much. I've already disturbed it. I've got a new tool here. It's my first chance to use it. Come on, it got to be written here somewhere. Should be right around here. Oh, 0.0. Oh, for crying out loud. Yeah, this is really working good. 0.02. That's a 0.02. It's supposed to be a 0.01. Would this be a 0.01? This is way far away. This one's actually associated with the volume control here. I think it's the volume control. 0.01, it says right on it. 0.01. 0.01, eh? Oh. What's going on here? Did I get the size mixed up? So I'm just going to, on my own, jump back on the schematic here briefly. And I'm going to say it's C10 we're looking for. And I'm going to say C10 is a 0.01. I'm looking now down the list of parts. There's a 0.02. There's two 0.02s. 19 and 20. This is a crazy deal. 19 and 20. 19 looks like one that may not be there. It has to do with the output transformer. At a glance, I don't see it. On the schematic, it's shown in dotted lines as if it may or may not be there. Maybe it's model specific or something. And C20. Can you find C20? I don't think there's a C20. I think C19 is the top number. What's going on here? Let me go back and look in the list. There's a C20, all right. Somewhere in this radio. Okay, I can't find it. Oh, here it is. It's another. Oh, this is something you would do if you had a phono connection. There's no phono input on this radio, is there? No. So there's some models with a phono input, and that has those two. So there's no 0.02 capacitors. So no 0.02 capacitors in this model of the radio, but I found one where I expected to find a 0.01. So I think the answer is it's a 0.02 where the answer is this is the capacitor. This has to be the capacitor. Well, instead of a 0.01, it's a 0.02. Okay, whoa, put it back. I got to make this thing oscillate here. We're going to do this scientifically. That's kind of laughable. Okay, we're going to plug her in. Let's get it going. What happened? How come it didn't come on? Oh, it is coming on. Very, very slowly. There we go. Now, the assumption here is the oscillation I'm going to start is occurring where you really want to tune the radio to. So in the end, you're backing off like I have done now, so there's no oscillation. The radio's performance is down from what it could be. I think it was this one. right there you can see the when you have a circuit that's just about to oscillate, it will boost any frequencies that are close to that oscillation. It'll cause them to ring a little bit, like shouting into a piano or shouting into a guitar. Listen. It was even, I heard it, there was a thunk. It was this thing moved into oscillation, but you couldn't hear the effect of the oscillation, but you could hear the thunk. Thunk, hey, that's a good word. No, I didn't hear it that time. Okay, maybe I didn't hear the thunk. I thunk I heard the thunk, but it's not true. Oh, read me right there. As soon as it breaks into its own oscillation, its operation is different. And sometimes just that difference can be heard aside from the actual oscillating tone. Okay, not quite the sound I would expect, a nice pure oscillation. I'm going to flip the radio over. I cannot turn this anymore. So if we got it oscillating, it's oscillating. Do this with it operating. I wouldn't normally do this with the radio operating, but I'm going to do it with this one. Don't retune it. I don't like handling things that are on like this. Okay, tone remained. Is it this? Well, why don't we just move this a long ways? So I believe what I'm doing by moving this around is I'm varying the capacitance of this circuit ever so slightly, just a wee bit. But we can hear the change in pitch. Humans are very sensitive to change in sound pitch, extremely sensitive to it. Well, that's why we love music. Isn't it doing the same thing, or is it the radio itself doing something? Because it's changing pitch and not returning. And of course, any other component could affect this thing too. There's a very sensitive way of doing this, but the effect may be unimportant. Like, for instance, if I can move this, I don't know what I'm moving. Ooh, moving all kinds of stuff when I do that. Just looking for anything that might be really sensitive. Ooh. So I'm touching something and the pitch is not going up and back. It's going up and sticking. Now it just came back. It could be loose tubes in the socket. You know, like tiny variations here are going to change this pitch. I'm looking for something that's super sensitive. There's something. This red wire here. So often these wires are being run close to the chassis to try to stabilize this issue, I guess. Stabilize or prevent it. It doesn't seem very sensitive now for all that poking. Okay, I don't think this little experiment's leading to... Ooh. That's from this tube here. I'm going to move this tube around a bit. Wow, lots of stuff is moving. So I'm wiggling the tube socket slightly. How about the next tube over? Am I going to get a shock here? I don't think so. Oh. The tone never goes away. That would be an important observation. Get my hand on the chassis here. Danger, Jim, danger. Okay, that's the next one. That's this one now. It makes a big difference. Stop now. Oh, it's because I was bumping this one. This is the guy that's making the difference. But the tone never goes away. Ooh. Oh. I finally hit something sensitive. So this is right on the local oscillator coil. So that's going to vary the local oscillator frequency. So we're getting, how's this happening? We're getting a tone out the speaker. It means it has to be coming Okay, too much to think about here. I started thinking, well, maybe this heterodyne tone is not coming from the IF thing, it's coming from somewhere else. But because of the sensitivity of the local oscillator. But I have to think a long time to figure out if there's any sense to what I'm saying. I don't think this is defective. I'm still going to go after this one. We'll see. So again, it doesn't go away. It's just changing pitch. That's the guy. Okay, that was fun. Turn the power off, and I'll change this out. I won't touch anything else. But I will go and drink some coffee now. Well, as is often the case, it looks like I'm completely wrong about what I'm doing here, but that's okay. I don't mind being wrong. So I put in a new capacitor. I've replaced the one that was here. I took it out expecting it to be 0.01 according to the schematic, 0.02 according to what I saw, but in reality it's a 0.05. 0.05. Let's check its condition, and then we're going to try to find this on the schematic. Now, maybe we can guess what kind of condition this is in. It's old and tired. So we're going to use this type of capacitor checker, which applies a DC voltage across it, and then the amount of current leaking through it, which should be just about nothing, will affect the magic eye here, which I'm trying now to stand in just the right spot. You can see faintly a shadow or a pie, unopened, like a dark pie down here. Keep your eye on that. 50 volts, what does it do? It's okay, so a good capacitor, the eye would pop open just like you see it now, even with the capacitor connected. This one, 50 volts is too much for it, so this is a bad actor. Now I'm going to show you on the schematic where a 0.05 is in this radio. Let's take a look at that. Okay, so if we go over here, we look down the list, 0.05 occurs here and nowhere else. C12, here's C12. So C12, why are they showing a negative here? That's a little odd. Why the negative here? Don't know what's going on here. C12 is a 0.05. There's no reason for it to be. Unless they're trying to mark the outside foil, or this is just some, I don't know, some. It's some. Okay, ignoring that. There's C12, and what is it doing? So on one side, it's connected to the B minus. Interesting, the minus is over on this side. other side is connected to the screen. So this guy's job is to quiet down the screen connections, I would say. So because you can have a signal in the screen here, if this capacitor weren't here, that signal would find its way to this wire, and this wire would take it over here and stick it into this screen. There's two screens in this tube here. So you'd have the signal developed here showing up over here, or vice versa. It's more likely to go from the the more powerful end to the more sensitive end, of course. So this could be the problem because of feedback occurring through the screens, and that might explain the lack of putt-putt. I wouldn't expect a putt-putt effect from this. Instead, we were getting a pretty clean tone, in fact, heterodyne tone. The actual frequency that's oscillating here, we can't hear it, but it's being combined with maybe the local oscillator or stuff in the IF at 455, and the combination is producing the audio tone that we can hear. That's how I would interpret that. So let's see what happened. I changed this. I put in a bigger one. I put a 0.06 in there because I'm out of 0.05s. Let's go to the radio now and see if this did anything. Did this do anything good? Well, it couldn't have done any harm. I can't imagine how that would happen. So only one capacitor changed. Radio's in the same state it was in before. Here we go. First the dim lights. The dim lights have done right. Maybe what was disturbing me here when I turned the power on last time was the light didn't come on. Of course, I have the light unscrewed. Maybe that was some kind of deep psychological thing going on. Uh-oh. I think I hear the tone. Then I hear the tone. Well, if anything, it's worse. And that's par for the course. Let's just tune the radio here. Oh, there it is. So this sound, interference sound, is interference. That's oscillation starting. That's full oscillation. We did not get it yet. In the background, you can hear the radio signal itself. The guy talking is best. Somewhere up in here. It looks like when the tone starts, it's triggering some AVC voltage. Not surprising. And that's going to quiet the radio down, so you're not going to hear the full effect on the actual signal coming through the radio. Be fooled, because as you tune it, bring up the signal coming from the antenna, at the same time this oscillation is causing the AVC to knock it all back. So it might end up sounding, as you tune through, kind of sound the antenna signal, the actual radio signal, makes it sound kind of level because of that. Well, I make so much stuff up, it's fantastic. Long live the human imagination. I think we're the only animal on the planet that has control over its imagination, that we can choose to do with it what we want. That's another one of the things that sets us apart from the other animals. Yeah. Well, I think I'm going to stop at this point, because we're later in the morning and it's getting a little warmer outside. Beautiful sunshine today. And we'll just try another one tomorrow and see if we can hit it, because that AVC capacitor must be in there somewhere, and it could even be up here. Could it be up here? Could be. I don't know. Okay, so thanks a lot for watching, and I'm off to enjoy the sunshine and cold air outside. See ya.